Hello, I'm Rugved Rajendra, and today we're going to be going through derivatives, definition of a derivative. So sometimes you're going to have a function like f of x equals 3x squared, and you won't know any shortcuts to use, but you need to find the derivative. Or maybe you do know a shortcut to use, like the chain rule, but your problem still asks you to find the derivative using the definition of the derivative. This video is going to come in handy for that. So the definition of a derivative is limit as h approaches 0 of f of x plus h minus f of x all over h is equal to f prime of x. So this may seem a little daunting at first, but let's go through an example. So if f of x is 3x squared, then using the definition of a derivative, f prime of x is going to be limit as h approaches 0 of f of x plus h. So let's just look at this first. If f of x equals 3x squared, then f of x plus h is going to be 3x plus h squared, since we're just going to put x plus h wherever x is. So instead of writing f of x plus h, we'll just write 3x plus h squared. Then next it says minus f of x. So minus, here we have f of x is just 3x squared all over h. Okay, so we have this so far, and now the next step is going to be to multiply everything out so then we can start simplifying. So first, let's move it here. Limit as h approaches 0. Now, if you factor this out, it's going to be x squared plus 2xh plus h squared minus 3x squared all over h. Then if you distribute the 3, it will be limit as h approaches 0 of 3x squared plus 6xh plus 3h squared minus 3x squared all over h. Now you guys might notice that this 3x squared and this negative 3x squared would just cancel out. And that's the thing about definition of a derivative. If you do it right, you'll always have the minus f of x part cancel out with one of the f of x plus h components. So since these two cancel out, we know we're doing something right. So if we rewrite it, it'll be limit as h approaches 0 of 6xh plus 3h squared all over h. Next, you guys might notice that the top and bottom both have an h, so we can just take an h out of the top. So limit is h approaches 0, h, 6x plus 3h all over h. And these two h's cancel out, so we are left with limit h approaches 0, 6x plus 3h. Now at this point, we can just plug in 0 instead of h here. The reason we couldn't plug in 0 earlier was because we had this h in the bottom, so then we would have a undefined or indeterminate value. So here, since there's no h in the bottom because we just cancel it out, we can just put 6x plus 3h, which is just 3 times 0, which leaves us with 6x as our final answer. So after all this work, we get that the derivative of 3x squared is 6x. And this may seem like a lot of work, but once you learn more shortcuts like the chain rule, for instance, this will go a lot easier. So if you do know the chain rule, you can of course just check your work. So if you have 3x squared and you want to find the derivative of this, swing 6 and subtract 6x to the 1, which is equal to 6x. So we know we're correct. Okay, now let's look at another problem. F of x equals 7x cubed minus 3x. So if we use definition of the derivative that we just learned, we'll get f prime of x is equal to limit as h approaches 0, f of x plus h minus f of x all over h. So for f of x plus h, we can set that equal to 7 x plus h cubed minus 3 x plus h. So here we can write 7x plus h cubed minus 3x plus h, and then f of x will just be minus 7x cubed minus 3x all over h. So first let's focus on the f of x plus h part and simplifying that. So if we multiply out x plus h cubed, we get x plus h times x squared plus 2xh plus h squared, which is going to give you, if you FOIL it out, x cubed plus 2x squared h plus xh squared plus x squared h plus 2xh squared plus h cubed finally. Then we're going to put all of this and multiply it by 7. So essentially we'll take this, bring it down here. We still have to multiply this by 7. And then of course we still have the minus 3x plus h, which we can just quickly multiply out in our heads. So that would be minus 3x plus 3h, which if we distribute the negative sign is going to become minus 3x minus 3h. So now, once we've done that, we can go ahead and multiply the 7 into each of these, which should be pretty simple. So x cubed will be 7x cubed, 2x squared h will be 14x squared h, xh squared will be 7xh squared. This again will add a 7. This will be a 14. And this will be a 7. And then we can't forget about the minus f of x part. And remember, you have to put this in parentheses so you can distribute the negative. So this would become minus 7x cubed plus 3x. Of course, this is all over h. This is limit as h approaches 0. So now we can start canceling things out. So we have a plus 3x here, minus 3x here. These two cancel out. We have a 7x cubed here, and minus 7x cubed here. These two cancel out. What else? I think that's pretty much it, because every other term has a h, which means we can take out a h like we did in the last problem. So if we rewrite it, we'll get limit as h approaches 0, 14x squared h plus 7x h squared, x squared h plus 7x h squared plus 7x squared h plus 14x h squared plus 7h cubed minus 3h all over h. Now since all of this has a h in it, we can take out an h, so that would be limit h approaches 0, take out an h, it would be 14x squared plus 7xh plus 7x squared plus 14xh plus 7h squared minus 3. Put that all over h. The two h's cancel out. And then we're left with limit as h approaches 0 of 14x squared plus 7xh plus 7x squared plus 14xh plus 7h squared minus 3. So now we can finally plug in 0 for all the h's since the h in the denominator is gone. So if we put in 0 here, this would go out. Put in 0 here, this term would go out. Put in 0 here, this term would go out. So we're left with our final answer being 14x squared plus 7x squared minus 3. Which again, we can check this with the power rule. So 7x cubed would become 21x squared minus 3, which is equal to this because 14x squared plus 7x squared is 21x squared minus 3. So since these two are equal, we have found the correct answer. Thank you for watching and have a good day.